So what we're going to cover now is how to containerize the agent. And primarily, if you would want to containerize the agent if you don't have time to rewrite your application as a cloud-native application, because that requires a lot of re-architecture and reworking and rewriting of your app. So this is kind of a quick and easy way to migrate existing workloads to a containerized-based workload and still utilize the agent and still utilize your job definitions that you currently have defined today. It really is just a matter of switching the machine definition. All right. So the very first part of it is you always have to start with a Docker file, and then you do build the Docker image, and then you export the Docker image, deploy the image, and then expose the service. And so this demonstration, what I'm going to show here is using a Kubernetes environment, which is OpenShift, which is the Red Hat variant of Kubernetes. But the same techniques should work fine with anybody's implementation of Kubernetes, whether it be Amazon, Azure, Google Cloud. They all basically have the same concepts. The Red Hat one has some extra ones, but the same concepts will work with both in regular Kubernetes as well. So to start it off, the first thing is the Docker file. So here is an example of a Docker file that I used to deploy the agent. There are some tricks I did in here where I used the agent ISO image, so you'll see that download location, which is pointing to an HTTP location, because I'm going to do a wget and transfer the image during the Docker build stage and run a silent install of the agent, system agent, inside of the Docker build stage. So the key thing is that the first part is it's just setting up some environment variables where the ISO image is located, the install location, there's a copy statement in there to copy some initial setup files and the response file, and there's the installation of certain utilities that are needed, and the last run line that you see in there is the actual, it's a big, massive pipeline of run commands, and this is done to keep the layers small. Because in here you'll see where we're downloading the image as well as extracting the image, ISO image to a temporary location, and then the running of the setup.bin and running it in silent mode. And then in this one it's installing a couple of plugins, as well as extracting a POJO implementation. So it kind of shows a little bit of everything in there. And the very last part is where it's exposing a volume. Exposing a port, so 7520 port, which will eventually get mapped to a service, which I will show later. And you can also utilize volumes as well to actually use persistent storage volumes to store certain items, which will be persisted among restarts. In particular, I have the database, the log directory, and the spool location. And then the very last line is a script that's used to keep the container running. So in any containerized application, whether it be Kubernetes or Docker, you have to have some application that is constantly running in order for the container to stay alive. As soon as that application or script that's running on the command line terminates, the whole container will be terminated and cleaned up by the environment. So this is a way of actually keeping it running. So a little bit about that command start script. So this command start script actually has some setup which actually allows you to pass environment variables to the container on deployment, and this will allow you to alter some of the settings inside of there. So you can customize this to any way you want. I'm only targeting specific things like the agent name, but you can also do it with the port, or you can do it with here I'm also modifying the etc host to add a server name if I wanted to put a specific server name in there. But you can really customize it to using a similar pattern that I've done here. And the very last line is what keeps it running. So in here, I'm actually running the agent in the foreground as opposed to running as a daemon process. Since the containers are specialized containers are specialized, And I'm only running an agent in this container. I don't have any applications in here. This is just a concept to show you how you can inject the agent into your existing Docker images. But for this purpose, I'm running the agent in foreground mode, which will prevent it from, prevent the container from exiting. Because when you run it in foreground mode, the agent stays running in the foreground. Okay, so next is the Docker image, building of the Docker image. All right, so this Docker image, will do a couple of things when it's doing the build. It's going to install the RPM packages, as I mentioned before. It's going to download the ISO images. It's going to extract the ISO image. It's going to run a silent install of the agent and the plugin. It'll copy some extra jar files for the POJO implementation. And at the very end, it will clean up. It will remove the ISO image, delete the extracted files, and remove temporary files. So it will try to reduce the size of the layer that's being used. So what I'm going to do now is show you that. So here I have my Docker environment. So the first thing you have is these files that I mentioned before. So I have a Docker file here. So this is the same Docker file that I showed in the presentation. So so it's exactly identical to what you saw in the presentation. And then in the setup directory is where the copy happens from, because you'll see here that it's doing a copy from the setup directory. So in that setup directory, I have an OpenShift the POJO that we were talking about in Valerie's slide, and the start script, and then the silent install script. So from here, with these files, I can actually run a Docker build. So what I will do is build it. So now it's proceeding to build the file. Okay, so it successfully built it. And then if I run the image, so this was the image that I built. And so the next step would be to actually export it. So I want to save the image out. So this will just save a tar file out, and then that tar file can be moved over. So let me switch back to the slides. So as a recap, here is the files that I was dealing with, and then I ran a Docker build, and then the next step would be to export and import. So I had started the export already, so this was the command I ran to export the image. And then the next thing that would happen after that would be the loading of the image. So there's a bunch of steps here about how to load. So you load the Docker image, and then you have to tag the image to put it into your Docker, your OpenShift repository, and then push it to the OpenShift repository. So what I will show about that is the deployment of the image now. So here I have saved the image out. So the image has been saved out here. So now I'm going to switch to my other environment, which is where my I have a mini-shift environment here, which is an OpenShift environment. So what I'm going to do is I'm going to SCP it here. ESP. So I'm going to copy it over to my other environment, which is this guy, and that's this machine here. All right, so this was the image that I just uploaded. So what I want to do now is I want to load the image. So I'm going to load it into my Kubernetes environment, into my Docker environment. So this will upload it into Docker. Then the next thing you have to do is tag it. So I'm going to tag it, and this is my my OpenShift Minishift Docker repo. So it's going to tag it, and then I'm going to do a push to push it out. So this will push it. So once that's done, now everything is set up inside of your environment that you can actually run. Let me switch back here. So that was deploying of the image, the exporting and deploying. So the next step would be to try to deploy the image. So here's some screenshots that I had about how to do the deployment from a OpenShift environment. It may differ if you're looking at like an Azure or an Azure Kubernetes or an Amazon Kubernetes, but they all support a deployment mechanism where you can do a deployment. And then the next stage is that it will, if you're using OpenShift, it'll bring up a wizard to actually do the deployment. And the last part will be exposed. So now let me show you the deployment updates. So once you deploy your image, the image will show up under here. So I had deployed the system agent K8S. So this is the new one I just deployed, and it says it was updated a minute ago. So I just uploaded it. So this image here is now available to use as a base image for deployments within the environment. So what I'm going to do now is go to Applications, Deployments, and you'll see here I had deployed some other stuff into this environment. And I'm going to hit here and say Deploy Image, which is that first screenshot that I showed, and this is the wizard that comes up. So from this wizard, you can see the images that are deployed into the registry. So I had deployed it into my project, and it was called sysagt 12k8s, and I'm just going to select the tag, which is the latest. So then it will populate it with this information here, and here it says that the port will be load balanced by a service, so it's going to create a service. It'll create the deployment config, and this is the name of the deployment that I'm going to create. And then from here, what I could do is since I had those environment variables that I had set before in the startup script, I can override the agent name. So I'm going to set the agent name to K8S will be the agent name. So what this will do is that when I deploy the image and the image starts running, this environment variable will be set up by the Kubernetes environment, and it will be available to the pod. So when the start script starts running, the pod will see that there's an agent name variable and use that value. And using the script that I had created to alter the name, you will see here if the agent name exists, it's going to modify the agent parm.txt and change the agent name to the name that I specified. All right, so all I have to do here is hit deploy, and that actually starts the deployment. So here you see the deployment's going out, and now you see the replica is running. So if I go to the overview, you'll see that I have one pod running here. Right, so now the next thing to do is that if you actually look at the deployment, you'll notice that the actually let me cover the slides first. So back to the slide. So next part is to expose the service. So when you do a deployment, at least in OpenShift, it actually deploys it using cluster IP. So what you need to do at that point is you have to modify it to change it so that the service is deployed as a NodePort so that you can access the agent externally from the cluster. If it's just cluster IP, then you can only access it inside the cluster. But to expose it externally to the cluster, which is the case I'm going to show, it will. You need to convert to a node IP, or you have to use a load balancer. But since I'm running in a mini-shift environment and it's a private area, I don't have a load balancer and virtual IPs available to me, so I am going to use a NodePort for this demonstration. So here you'll see I brought up the YAML file for the service definition, and you'll see it says, I highlighted in red here, the type is cluster IP, and what I'm going to do is I'm going to edit it and change it to NodePort, like what I showed in green on the right. Right? And once the NodePort has been modified, you'll see the NodePort show up here underneath the route. Okay, so let's switch back over to the screen share. So what I'm going to do now is I am going to jump over to the service that was created. So the service was created here, the sysagent 12K8S, and you'll notice that there is no route specified here. It's currently set to none. So if I go into the YAML, and here's that same file that I showed in the presentation, and change this one to NodePort, and then save it, what will happen is that the NodePort will get assigned. Now, there's something unique about NodePorts in the Kubernetes environment. NodePorts have to exist in the 30,000 plus range. So NodePorts can only be 30,000 or higher. You cannot use a NodePort that's less than 30,000. And so what's going to happen here is that the Kubernetes OpenShift environment has exposed this port now so that it's available externally to the cluster. And once it's exposed externally to the cluster, then I can, access it from external applications. And in this particular case, I will use a dSeries system to do that. And just to show you that the pod is actually running and has been modified, so when I go here, this is actually allowing me to get into the pod. And from within the pod here, it's kind of small. Let's see if I can make this bigger somehow. It's not much bigger. Hopefully you guys can see this. So if I was to ps grep and grep for the system agent process, you'll see it's currently running here. And if you look at the installation location, it's here. And from here, I can take a look at the agent parm and show you that the agent name was updated to K8S. The port is still set to 7520, and I'm using a custom crypt key, which was specified in the silent install. And any other unique things about this environment, and you'll see the normal files that you always see. The log files are here, so the regular log files will show up as such. So that should be it for that. So now I'm going to switch back to what the dSeries settings look like. So here you'll see a screenshot of how I set up the dSeries environment. And in particular, I created a K8S agent, and you'll see that I gave it a name, K8S, the address, and it's using the AES encryption. And then you'll see the port number is set to the NodePort. So for a live demonstration here, so in this particular environment, I need to get the NodePort that I just set up. So the service was this guy, and it's using NodePort 32 385. So I'm going to switch over to a dSeries environment. So this is the I think SP1 release of dSeries. And I have this NodePort. I already have a machine definition here, so this is what I had from before, but I have now changed it. So I have, K8s was the agent name. This was the machine name where the cluster is running. And this is where the NodePort is exposed. And I'm going to put the NodePort in here. This is my encryption key. It's just a simple 32-character number. And I'm using AES encryption. So I will save this. And then the agent became active. So it's now running. And if I flip over back to the actual pod, so what we can see now is if I go into the logs directory, and I'm going to tail the receiver and the transmitter. So in here, you'll see some stuff about, here's the message coming in from the D server to register itself against the agent. And then here you'll see, it's the agent responding back to the D server. So what's going to happen now, what I'm going to try to do is I'm going to try to execute a command job to run inside of there. So here I set up a simple, just a Unix job. It's not doing anything fancy. And I'm going to try to run an ls command. Now, I was trying to run it as root. Now, there is an issue with containers where in the OpenShift environment especially, there is no such thing as users inside of these environments. So you'll notice that the agent itself is also running as a random user generated by Kubernetes. Right? See, the user is this. And in fact, when I'm logged in here, I'm logged in like this. So it doesn't really have UID 0, so it doesn't really have all the privileges of root. Right? So, but that's something very specific to these type of environments where there really is no concept of users, and the agent doesn't really run as root because you're not allowed to run as root inside of the container. It's a simulated root because it's using a UID of large number as opposed to 0. So if I was to run this job now, so let's trigger this, and now what I want to do is I want to show when the messages will come in. So I'm going to clear my screen here and and then trigger this job. And the job. So the job ran to completion. So if I flip back over to my agent screen, you'll see here the incoming messages. So here you'll see here's the run command of the ls. And this is the response coming back. So here you'll see state exec and the job executing, and then the job going to completion, just like you normally would see in the regular environment. And if I was to go back into dSeries and look at the generation, I think I should be able to retrieve the spool. And there's the output. That was it actually ran, it did an ls space slash, which is just doing an ls of the root home directory, a root directory. And this will match the root directory of Anaconda, post, and bin dev. So if I look at the root directory of this agent, you see the same thing: Anaconda, post, bin dev, etc. So once you have something like this set up, then it becomes very easy to deploy extra agents in your environment. So say, I already have the image deployed. Now I already started one agent. Now I want to deploy a second agent. All right, so how would I deploy a second agent? I could just go into here, click Deploy Image, select the image again, and then all I have to do is change the name here. I'll just put -1, and then I'm going to give it another agent name, and this time I'm going to call K8S-1, and then I'm going to deploy it. And within a few seconds, I now have 2 system agents running on this machine, 2 system agents running. Right? So I have this K8S1 and I have K8S-1. And I have to go through the same thing again where I need to, since I'm using NodePorts, I want to change the K8S-1 and add the, set up a NodePort. So I'm going to switch it cluster IP to NodePort and save it. So now I'm running on 31.468. So I have a second agent now running on 31.468. So I have 2 agents running on this one, and I have this one. So they're 2, both of them are all running, and I have pods running underneath there. So you'll see all these pods. You'll see these 2 pods running, so they're 2 separate. So if I want to use that second agent now, I would just have to go back into my scheduling engine again. Go back into admin, go to topology, and it would be very similar to this one. So I'm going to say add new agent, call unit. I'm going to call this K8S-1. And the port I'm using was this port. And I need the host name. So let me grab that host name. So this was the host name. Paste that here. And it's using the same AES encrypted key, so 1, 2. And it's using AES encryption. So when I save this, it goes active. So now I have 2 agents running. So within, a few minutes, I was able to actually create a second agent. And, you can keep doing this throughout your whole cluster, creating more and more agents. So, so the key thing here about when you want to use an agent for your existing thing, existing application. So if I have an existing application, say it's running a script or an executable or something, the easiest way to migrate it to a container is to containerize your application and then use the Docker, the pieces from the Docker file here that I set up into your own image. So, basically you would need, this line here to create your own image. So you probably have other run lines that install your application and configures your application, but this, and then you would add this stuff and the expose, and if you want to use some volumes to create your own image and inject it into your existing Docker images for your applications. And then once you deploy that, you use the same technique that I just did to deploy it and expose it, and you'll be able to just run your workload just as before. All you have to do is change the machine definition to point it to your new Dockerized application.
Thank you and have a great day.